Assalamualaikum and hi everyone. I am Nur Hasrini binti Asmadi from ED 247 and today I would like to share about river pollution and in specific the pollution that caused by microbial activities. I hope all of you can gain new knowledge from my sharing. Let's start. First thing that you should know is objective. There are two objectives of my case study, which are, first, to investigate river pollution in Malaysia that caused by microbial pollutant, and second, to examine the effect of pollutant on human health. Before we go further through the case study, let's take a look on this article from the Straits Times. The title is Malaysia River Pollution Cuts water supply to more than 300,000 people in October 2020. Two water treatment plants were shut down due to the detection of pollution in Sungai Semenyih, which is the raw water source for the plants. It proved that river pollution is a big issue in Malaysia. Let's take a look on my case study. The first article is Assessment of the characteristic of nutrients, total metals and fecal coliform in Sibu Laut River, Sarawak, Malaysia. Based on the bar chart here, we can see fecal coliform generally low during high tide and all of the stations contain less than 2 CFU per mil. The highest fecal coliform during high tide was found at station 2. During low tide, fecal coliform was found highest at station 5, which is 40 CFU per mil. Station 5 is near to the discharge point of the shrimp farm. Fecal coliform was steadily decreased at station 5 to station 3. Besides, fecal coliform was also found high at station 9 and 12. Fecal coliform was low at the rest of the station during the low tide. The second article is Distribution and Characteristic of Bacteria in Recreational River Water of a Community Resort in Baram, Sarawak, Malaysia, Borneo. There is no fecal coliform that being counted in this research. Researchers only identify the bacteria that present in the area and they are resistant towards certain antibiotics. One of the antibiotics that being used in this research is ampicillin. Researchers mentioned that the level of resistance is quite low. The reason for the comparative low resistance is that the isolates were taken from environmental water where the source might not be exposed to domestic or industrial runoff. Researchers use API kit to confirm the presence of Enterobacter, Klebsiella, and Serratia in the water samples. So, from the table, we can see that there are the presence of Enterobacter in Tenyok River. In Nyang Waterfall, Enterobacter and Klebsiella are identified, while in Nawan Waterfall, Enterobacter, Klebsiella as well as Citrobacter are found. These bacteria are dangerous because Klebsiella accounts for most of the urinary tract infection in the world, and Enterobacter has been associated with various diseases ranging from respiratory tract, urinary tract, skin and soft tissue infections to bacteremia. The third article is Identification of polluted sites in 4 major rivers in Kuantan, Malaysia based on water chemistry estimates of aquatic microbial activity. This article did not focus on the concentration of microbial pollutant, but researchers only mentioned that it might be the microbial activities in the river. In 3 of the rivers, the Pahang, Kuantan, and Belat, a lower concentration of ammonium was detected, which is likely attributable to aerobic biological reactions. Galing River shows significant difference where it contains lower dissolved oxygen and higher ammonium concentration. It implies high consumption of the dissolved oxygen in the river water due to the high microbial decomposition of the high concentration of organic compounds. The fourth article is Microbiological and Physiochemical Water Quality Assessment of River Water in an Industrial Region of the Northwest Coast of Borneo. As you can see from the table, fecal coliform ranged from 23 mpm per mil to more than 1600 mpm per mil at Site 1 to Site 10. Fecal coliform at Site 9 is the lowest, with 23 mpm per mil, while fecal coliform at Site 2, 6 and 10 are the highest with more than 1600 mpm per mil, which indicates the possibility of contamination with human or animal waste and also pathogenic bacteria. The fifth article is Assessment of Microorganism Pollution of Selangor River, Malaysia. Based on the bar chart here, you can see that the highest number of both total coliform and E. coli can be observed at Station 8. E. coli at Station 8 is 100,000 mpm per mil, while the total coliform at Station 8 is more than 100,000 mpm per mil. E. coli also significantly high at Station 5, 8, 9 and 11. It may due to the direct discharge of wastewater from septic tank, since those stations are located at Rawang Sub-Basin, which represents the main river for urban wastewater discharge, effluents from septic tank and industrial effluent within Rawang industrial areas. Those are the results from 5 different articles. Let's continue with the discussion. The presence of fecal coliform is compared with the standard given by the Ministry of Environment and Water. Research that conducted in Cebu, Sarawak shows that the water fecal coliform is below 50 CFU per mil, which falls under the Class 1 where no water treatment needed. However, for the research that conducted in northwest coast of Borneo, it shows that the highest fecal coliform was more than 1600 mpm per mil, which falls under Class 3, where intensive water treatment required. Lastly, research that conducted at Selangor River shows the highest total coliform of more than 100,000 mpm per mil. It is far exceeded the acceptable value that highlighted by Ministry of Health. So, last but not least, let's take a look on the last slide, which is conclusion. In a conclusion, based on the 5 articles that been discussed, Cebu Laut River, recreational river in Baram, Sarawak and 4 major rivers in Kuantan are safe enough. But for the river water at the northwest coast of Borneo and Selangor River, both are exceed the standard that's set by the Ministry of Health. Therefore, water treatment is needed. So, I hope you gain something from my sharing today. That is all from me. Thank you.